Next slide. This slide is about the basics of gases. Three things describe a gas. One, the temperature, which is the measure of the random motion energy of the gas particles. Two, the pressure, which is the amount of force per area. And three, the density, which is the amount of mass in a given volume. The relationship between those three things is the equation of state. A cool gas produces low pressure, while a hot gas produces high pressure. Atmospheres are poofy. The outward thermal and radiation pressure is balanced by the inward gravity compression. The atmosphere is in hydrostatic equilibrium. If the Earth's atmosphere was frozen, gravity would cause it all to collect on the surface to form a layer of nitrogen, oxygen, water, argon, etc., ice, about 12 meters thick. However, these materials are in a gaseous state on Earth and make a layer over 60 miles, that's 100 kilometers, thick. Greater gravity compression makes a gas hotter, so it can produce greater outward pressure to balance things out. The lower atmosphere nearer the surface feels a greater compression from the overlying layers, so the pressure must increase to keep the balance. More weight means more pressure and higher temperature. Next slide. The surface temperature of a terrestrial planet is determined by how much energy it receives from the sun and how quickly it radiates that solar energy back to space. A terrestrial planet's interior temperature is determined by its size. The crust is a very poor conductor of any heat from the mantle or core. Three things affect the surface temperature. One, the distance from the sun. The closer the planet is, the hotter it will be. Two, the surface reflectivity, known as the albedo. A planet with greater reflectivity, an albedo closer to 1, will be cooler because it is absorbing less energy. Clouds and ice reflect solar energy. 3. The planet's atmosphere can trap heat in what's called a greenhouse effect. The greater the greenhouse effect, the hotter the planet will be. A planet's atmosphere can also hinder the rate that energy flows inward from space to the ground. The moon and the Earth are at the same distance from the sun, but the moon has a very large change in temperature from day to night due to the moon's lack of an atmosphere. The moon's surface temperature at its equator ranges from about a negative 173 degrees Celsius at night to almost 127 degrees Celsius during the day. Next slide. We've known for about 150 years now that certain gases like carbon dioxide or water vapor in the atmosphere prevent heat energy in the form of infrared light from leaking out to space. On Earth, water vapor supplies most of the greenhouse effect because of its greater abundance in the atmosphere, but per molecule, carbon dioxide is a stronger greenhouse gas. Water vapor also has a much shorter time that it stays in the atmosphere, only about a week, because of its greater sensitivity to temperature changes, while carbon dioxide can remain in the atmosphere for decades. Visible sunlight provides the input energy to heat up the surface. The surface re-emits the energy in the form of infrared, which has a harder time getting out. Infrared is the output. If the clouds were to become perfect reflectors of the input energy, then the surface temperature would cool off just as surely as removing a pan from a hot stove top cools the pan. If the greenhouse gases were perfect in absorbing the infrared energy from the surface temperature would get hotter and hotter until it was as hot as the sun. A balance is reached between what is coming in and what is going out. A little greenhouse effect is necessary to keep our oceans from freezing, but too much greenhouse effect is not good. We'll talk about Venus a bit later. Further down on the slide is information about the layers of the atmosphere, which are determined by how the temperature changes with the altitude. Our weather with clouds, convection, and wind, and greenhouse effect occurs in the troposphere. Of the terrestrial planets, Earth is the only one with a stratosphere layer due to ozone absorbing ultraviolet light and heating up.